Yeah, I did. 140, or yeah, 147.
I just didn't comprehend. Unit 3 is this test is going to be the death of my gone.
It's packed with information, that's for sure. All right, so section 3.5. Again, we're dealing with power series, which we've talked about for the past two sections, but specifically in this section, we're going to talk about the geometric series. So thinking back to all those tests you have memorized, and we're going to talk about the geometric series. Those are going to be important for you to use on the test, so you need to keep looking at those note cards because they're not going away. They're going to be used. So we're going to talk specifically about geometric series today. A particularly important skill to develop for the AP exam, other than checking that you're in radian mode, is to represent certain types of rational functions as a geometric series. Rather than producing the power series using Taylor's rule, so we used that a couple sections ago, creating all of these series out of using Taylor's rule, taking the derivative, second derivative, third derivative, all those coefficients. We are going to develop them by manipulating a geometric series, or once we continue, manipulating any series that we've talked about. So we have the sine of x, cosine of x, e to the x, those ones we've had memorized, being able to manipulate those so we don't have to redo Taylor's rule for those to recreate them. So we're going to go through multiple examples today of ones that we should have possibly memorized and then just manipulate that series. So it says in some cases we're going to be able to do that by long division. We're going to go through an example of that today also to create a series. So example 1 is just going to be some review material. So a review of geometric series. So they are formed by multiplying a common ratio of r. So thinking back to the geometric series, it's a summation of what? Just generally, what is it? Summation. Yeah, and what's r? Ratio. So you think of a ratio to a power is what you need to think of. We're also going to talk about it. Well, yeah, we're going to talk about it in these examples too. So geometric series, when they converge, what does it converge to? Okay, so the first term over 1 minus the ratio. Very good. So we're going to use that in these problems too. So we're going to start with A1. It says, suppose I told you to start with A1 equals 1. So that would be your first term. And let the ratio be 2/3. What would the geometric series, or how would you write the geometric series? So again, think of it as a summation, so we're going to be adding something. The first term was 1. What would the second term be? They're giving you the ratio. So what is the second term? Think about that form that Autumn told us. It's a r to the n, so it's 2/3, yes. What's the next term? Yes, 4/9. And we'll just stop there. Again, that's going to continue on. It's just r to some power. And that rule would be 2/3 to the nth power. Again, some ratio to a power. That's a geometric series. So if I want to find that s, or what it converges to, we said s was equal to, and Eric gave us the a1 over 1 minus r. So what is the first term? 1. Over 1 minus, what's the ratio? 2/3. So what does it converge to? Sorry, what was that?
3.
Yep, 3. So 1 over 1/3, which simplifies to 3. So again, that's using a geometric series. So let's do the same thing with B. We're starting with 1 again. What's the first term? Or second term, sorry, second term. Negative 2/3. What's the third term? Plus 4/9, yes, because you're squaring. And the pattern would continue on from there, plus or minus. So what is the rule for this one? How do we write the nth term of this one? Negative 2/3 to the nth power. Find the summation. So before we actually find the summation, thinking about the problem, what we did in the first one and second one, should the summation, should it converge to a lower number or a higher number? Lower, because we keep subtracting off values and adding values. So it should converge to a lower value. Again, first term was 1 over 1 minus the ratio. So the ratio is negative 2/3. So what does that converge to? 3/5. All right, so not too bad so far. On the third one, they're telling you again the first term is 1. And they're telling you this time, instead of having this ratio, we're going to represent this ratio with an x value. So x is some ratio that we don't know. So what would be the second term? It's going to be 1 plus what? 1 plus x squared plus x cubed plus dot dot dot. It's going to be x to the n. Before we find the summation, does this look familiar? It is. Do we remember what we had this memorized for? I think it was it e to the x? I think, yeah, I think it was the new one that we were talking about. The 1 over 1 minus x. This is what this was, the new one that we had written the other day. So let's find the convergence for the geometric series. What's the first term? First term is 1 over 1 minus x. So again, I did mention the other day in class that one was similar to a geometric series, that we would talk about it later in the next section. So this one here, the convergence is 1 over 1 minus x, and we had found that series was 1 plus x squared. So we had already talked about this one in the last section. We're going to use this one a lot today, and it's going to be similar to the last section, but we're going to manipulate this one since we've already have it memorized as 1 plus x squared plus x cubed. We're going to use this one and manipulate it today. All right, so example 2. Verify your answer from example 1c by finding the power series of 1 over 1 minus x centered at c equals 0 by using Taylor's rule. Well, we've already done that. We did that in the last section, so we're not going to repeat part A. Using Taylor's rule, we had found that section, or that series. Part B, using long division. So that's where we're going to start today. We're going to find that series by using long division. So what it's telling you to do, it's telling you to take 1 and divide it by 1 minus x. So using long division, what's the first term? Has it been a while since we've actually done long division? Yeah, so 1. We need to pick whatever would make this a 1 down here. So 1 times 1, this is 1 minus x. And again, you subtract those. That's going to leave you with 0. Minus negative x, you're left with plus x. Okay? So now, what can you multiply this 1 by to give you x? You can multiply that by an x. So that gives you the x minus x squared. And again, you're subtracting those. So the x's go away. Minus x squared gives you plus x squared. What times 1 gives you x squared? X squared. So then you can go again. So you get x squared minus x to the third. Subtract those, and it's going to continue on. You get x to the third. So you'd get plus x cubed up here, and this is just going to continue on in the pattern of x to the n. So that's another way to derive this one, is actually do the long division. They're telling you 1 divided by 1 minus x. If you actually do that division, you get 1 plus x squared, or plus x squared, and continues on plus x to the n.
I have a question. When you're bringing down your x, you're ignoring a negative. Why?
Right here, this is 1 minus 1, and then this is minus a negative.
Oh, okay.
So positive. And then minus negative x squared, positive x squared. Minus negative x to the third here, so positive x to the third. Okay. Yep. And really, this is a 0 up here. So 0 minus negative x squared, or negative x, so it just changes it to a positive. All right, so that's part B. We confirmed it by long division. Let's confirm it by finding the radius and interval of convergence. Again, we did that last section. What test did we use most often when finding the radius and interval of convergence? Yes, we used the ratio test. We're going to do the ratio test on x to the n. That's what we're looking at, the x to the n. So we take the limit as x goes to infinity. The absolute value of what? Using the ratio test. And we're doing the ratio test for x to the n, so what goes in the absolute value? Not just x. Well, okay, simplified version, yes. I want the original first, then we'll simplify it. How did you get that?
X to the n plus 1 over x to the n.
Yeah, so using the ratio test, that would be your initial setup, x to the n plus 1 over x to the n. And Eric's correct, that's going to simplify to x. And using the ratio test, what do you want that absolute value of x to be less than? 1, yes. So the radius is what? What is the radius? Yes, it is 1. The radius is 1. So we found the radius, now we find the interval of convergence. Well, think about this interval. We know the radius is 1, that's how much it differs on each side of our center. Where's our center? 0. Is there anything added or subtracted to any of the x values? No. So the center is at 0, so the interval is going to be, and again, we put brackets and parentheses till we know which one's correct, because we don't know yet whether it's brackets or parentheses. So we know we're going from -1 to 1, because we can go 1 unit to the right, 1 unit to the left from our center, because our radius of convergence is 1. Now we have to test each endpoint. So we're going to test -1, and then we're going to test 1. So really what we would be testing is the summation n equals 0 to infinity, -1 to the n, and the summation of n 0 to infinity of 1 to the n. Each of these, diverge, converge, 1 diverge, 1 converge. What are we thinking? Eric?
Well, I think I asked this question last week, but we have the interval of convergence, but like, what is it converging to? Like, it's just...
Yeah, in this case here, we don't know which one it's explicitly representing, so that's what we had talked about. And I had done some more looking online, and I haven't found a clear-cut answer yet. So I'm not sure if that's something maybe we want to talk to Mrs. Bauer more about. But I was reading some things online, and everything I was reading would have just confused us more, trying to explain it the way I was reading it online. So again, in some of the videos I watched online, it's just something that represents some unknown function. We don't know what that is, but we know that we're representing it within that interval. So I know it's kind of hard to understand that, but there's some function out there we're representing that's unknown to us at this point, but we know if we found it, we would be exactly representing it within that interval.
So couldn't we say that for like the entire graph? Like, it's converging to an entire other graph that's out there we just don't know? Like, why is it only that interval?
I'm not sure. That's a good question. So we're going to have some time at the end of class. We can look some more and see what we can figure out. Okay? All right, so converge or diverge? -1 to the n and 1 to the n. Yep, they both diverge. So our interval is actually -1 to 1 with parentheses. And that's all they're asking us to do in this problem, find the radius and find the interval of convergence. All right, so now that we've gone over this with 1 over 1 minus x, on the back, we're going to start doing some more problems that are very similar to this. So example 3, we're going to find the power series of 1 over 1 plus x with the center at 0. Again, it's important the center's at 0 because that's what we dealt with the original one that we memorized. It was at 0. So all of these have to have the same center to manipulate them, so without going back to the Taylor series. So then find the interval of convergence and include the first 4 non-zero terms and the general term. So what they're actually telling us to do is substitute what into 1 over 1 minus x? What are we substituting into? If you think about how this is different. Originally it was 1 over 1 minus x. So what are you substituting into x to make it 1 over 1 plus x? Yeah, we're going to substitute in the minus, so it'll be minus x into 1 over 1 minus x. So we know the original one, 1 over 1 minus x is 1 plus x squared, x to the n. That's the original. Now the one this problem is asking about is 1 over 1 plus x. So again, into the x, you're going to have it a negative x now. So 1 minus x, well, what's negative x squared? That's just a positive. So plus x squared. But everywhere there's an odd power, it'll be minus. So that really is like having the alternator. Negative 1 to the nth times x to the nth. We okay with how we found that? Yep. All right, and if you do the same thing, again, they want, well, 4 non-zero terms in the general, we did that, and finding the interval of convergence. Again, ratio test. So if you think of the ratio test, limit, n going to infinity, absolute value, that gets rid of your alternator. So you're doing x to the n plus 1 over x to the n again, which is x, so the absolute value of x, but you still have to check your endpoints now. So this is the same, our radius is 1, the center is at 0, so we know the interval is going to be negative 1 to 1, but we don't know parentheses or brackets yet. So testing it, summation, n equals 0 to infinity, negative 1 to the n, and negative 1 to the n. And then we need the summation, n equals 0 to infinity, negative 1 to the n, because that's the alternator, times 1 to the n. So the first one, negative 1 to the n and negative 1 to the n, it's going to be negative 1 to the 2n. And this down here is just negative 1 to the n. We okay with that? All right, so now converge, diverge. Negative 1 to the 2n and negative 1 to the n. Diverge. So again, we have parentheses, negative 1 to 1. That's your interval. Good so far? All right, so number 4 is going to be similar. Erase a little bit that there. So this power series is going to be x over 1 plus x. Again, center at 0, that's important to us. Find the interval, 4 non-zero terms, and the general term. So we're going to go through the same process. Again, we know the original, 1 over 1 minus x, 1 plus x squared, dot, 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 x to the n. So we know that's the original. Again, writing it will help us remember that. 1 over 1 plus x, that's the one we had from up above. 1 minus x plus x squared. And again, that pattern is going to continue, minus x to the third dot dot dot. Now the one we're going after would be x over 1 plus x. So think about this. Remember, we said this is like a geometric series because we saw that summation on those first few examples we tried. So what changed with this example 4 compared to example 2 and 3? What do we need to do?
Multiply by x.
Okay, multiply it by x. Another way to think about it, the top, if we think about geometric series, was our first term. So examples 1 and 2, our first term was 1. This one, what's our first term going to be? X, yes. Another way to think of it, like Eric said, multiplying it by x. So 1 over 1 plus x, multiply everything by x. So x minus x squared plus x cubed minus x to the 4th dot dot dot. We have an alternator because it keeps going back and forth, so negative 1 to the n. X is going to be to what power?
N plus 1.
N plus 1. Okay, again, so now we have the power series, but we need to do the ratio test on it. So what we've been doing the past 2 sections, again, ratio test, limit. N goes to infinity. Absolute value, so that gets rid of the alternator. Again, the n plus 1 power on the top, well, that would be n plus 1 plus another one. So it's x to the n plus 2 on the top. And x to the n plus 1 on the bottom. Once again, simplifies the absolute value of x. So our radius, once again, is 1 for this problem. So it's going to be negative 1 to 1 again. And we just have to double check our endpoints. So again, you're plugging that back in. We would have summation 0 to infinity, negative 1 to the n, negative 1 to the n plus 1. So that's negative 1 to the 2n plus 1. Is that going to change or make it converge or diverge? It's still going to diverge. And without writing the other one, we would get negative 1 to the n times times 1 to the n plus 1. So negative 1 to the n, is that going to converge or diverge? It's also going to diverge. So the other one, I didn't write it out, but they will both diverge. So our interval, once again, open interval, negative 1 to 1. So basically what we're doing so far, and we're going to do a few more examples, what we're doing is manipulating this, and it's still within the same interval. So we mentioned in the last section that you could do manipulations and the radius is going to stay the same, but it's going to change what it's representing. So these power series, each one of these, represent some different function. Again, it's some unknown function that we're talking about, but we manipulated it. Within that interval, we can guarantee there's some function it's representing that we don't know at this point, but within that interval, negative 1 to 1, it's exactly representing that other function. All right, example 5 is one more manipulation. This is going to be our last one for today. So example 5. Have a good day, Caitlin. Find the power series of 1 over 1 minus x squared. So everywhere we have an x, all we're doing is substitute x squared into 1 over 1 minus x. Because we still have the subtraction there, the only difference is the x is squared. So 1 over 1 minus x squared, everywhere we have an x, put an x squared. So 1 plus x squared plus x to the 4th plus x to the 6th dot 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 x to the 2n. So again, that's the original 1 over 1 minus x. Just everywhere there was an x, we put x squared. We did at least 4 terms in the general term, so now we need to do the interval of convergence. Limit of the absolute value, x to what power goes on top? x to what power on top? The bottom is x to the 2n. That's our original. Which is on the top? 2n plus 2. Yes, remember, n becomes n plus 1, so you have to distribute the 2. So 2n plus 2. Okay. And if you simplify that, you're left with x squared. So the absolute value of x squared less than 1. Does the absolute value of x squared less than 1 simplify further? Simplify further? Okay, so we're just going to leave it still less than 1. If you so x squared, that becomes absolute value of x less than 1. Because the rule for the ratio test is less than 1. Okay? So now we know the interval, or the radius, again, for this problem is 1. Centered at 0, so we're from negative 1 to 1 again. And just verifying your endpoints. Summation of negative 1 to the 2n. And that's going to diverge. And the other one is just going to be positive 1 to the 2n, which also would diverge. So I didn't write them both out, but they both diverge. So once again, your interval, negative 1 to 1. So we've seen through all these manipulations, the interval has not changed. We're on the same interval. All of our manipulations have not affected that interval. They've just changed what it's representing within the interval. Okay. So we've substituted different things in for x, started with different first terms, but our center always stayed at 0 for these examples. And the interval stayed the same. Just what the actual interval was representing has changed. All right. And that's it for today. Eric will take a look and see what we can find. But